All right, friends, welcome back. In this video, I'd like to go ahead and take care of part 2 of day 2 of section 1.6 of your textbook. And so in this video, we're going to talk about how to solve radical equations. Okay, so these are going to be the ones where we have the square roots and the cube roots in our equations, and we just need to be familiar with how we go ahead and solve those. So 3 different situations that'll pop up here. You'll have equations that just contain one radical. You'll have equations that contain 2 radicals and nothing else. And then you'll also have equations that you'll have 2 radicals and then some more stuff, like a plus a number or a minus a number or something like that. So in each one of these cases, because the way we get rid of a square root is we raise both sides to the power of 2, the way we get rid of a cube root is we raise both sides to the power of 3, and et cetera, we are going to have to take a look at these 3 special cases and really kind of pay attention to when we have 1 radical or 2 or maybe 2 radicals and some other things that we need to take care of. So in the case where we just have 1 radical, that's the easiest case because you would just want to go ahead and isolate the radical and then undo it and then write your answer, okay? And that's this yellow case right here. So a couple of examples of that. I already have some examples worked out just for sake of time in the video. If you were to take a look at numbers 1 and 2, right? So you have 1 radical in these equations, and what you would simply want to do is just go ahead and isolate the radical first. In number 2, that was already done for you. It already had the radical by itself on the left-hand side. Radical of 5x is equal to 10. In which case, you would then proceed by undoing that radical by raising both sides to the appropriate power, okay? So remember, the way that you undo a radical is you raise both sides to a power that is the same as its index, okay? In the case of number 1, we had to add a 2 to the other side first so that we get that radical by itself on the left-hand side, and then after that, we're going to raise both sides to the appropriate power. So because that was a square root, the index would be 2, we're going to raise both sides to the power of 2, okay? And then you can see there that just turns into a couple of 1- and 2-step equations there. So after that, really nothing too mind-boggling there. In the case of number 3 in the notes here, we have this equation, which I'd like to go ahead and take you through here because we have x showing up both inside a radical and outside a radical, okay? Well, the steps for doing these are going to be the exact same. We still want to go through and isolate that radical as much as possible. And so if I'm looking here, I am noticing that there are 2 things that I need to undo on the left-hand side until I can get that radical by itself. So namely, I have a plus 4 that I need to undo, and I also have this negative 1 times on the outside. I have to undo both of those before I can start raising both sides to a power of anything, okay? So we need to isolate first, and then we need to undo, okay? So we are first going to go ahead and bring that 4 over to the other side, in which case we would just have an expression, right? Those are not like terms, so I just simply say x minus 4. And then after that, I need to go ahead and get rid of that negative that's out front. And I could do that pretty easily by multiplying everything or dividing everything by a negative 1. I think it might be a little bit easier if we think about that as multiplying everything times a negative 1, because then on the left-hand side, I just get the positive square root of 26 minus 11x, and that is going to be equal to negative x plus 4, just changing those signs there, right? And so it would be at this point that I now want to go through and raise both sides to the power of 2. And before I do that, I'm just going to go ahead and take my right-hand side. Since it's negative x plus 4, I'm going to go ahead and rearrange that so it says positive 4 minus x. That would be equivalent, and that's just going to make it easier for us to kind of see a little bit later on here. So I'm just going to go ahead and raise both sides to the power of 2 really quick, and then that's going to undo that radical on the left-hand side and just leave me with 26 minus 11x, and that is going to be equal to 4 minus x all squared. And the reason that I chose to write it like this is because I think it's a little bit easier to recognize that what you have here is something that looks like u minus v squared. And we have a special product formula that tells us exactly how that's going to expand out. You could write 2 copies of this and FOIL it out if you wanted to, but remember those special factoring formulas is going to help you out a lot here. So if you ever have this, remember that this is equal to u squared minus 2 times u times v plus v squared. Okay, and so applying that here, playing the role of v is 4, so we'd start off with u squared, or in other words 4 squared. That's going to make 16, and then we would subtract off 2 times u times v. That would be 2 times x times 4, and that of course would make 8x, and then of course we want to go ahead and add on whatever v squared is here, and so that is going to be x squared for us, okay? And so you'll see that we took our radical equation and we have worked with it enough, and now what we have here is just simply a quadratic equation. And so what we're going to go ahead and do now is collect all of our terms to one side and then solve it just like a regular old quadratic equation. So I'm going to go ahead and bring over my 26, And kill two birds with one stone here. Let's go ahead and also add the 11x over to the other side here. So we get 0 by itself on the left. And that is going to be equal to what? Well, let's go ahead and write this in standard form. So that's the x squared coming first. And then we have negative 8x plus 11x. That's going to give us a positive 3x. And then we have 16 minus 26. That's going to give us a negative 10. Okay? And so it would be at this point that we would want to check to see if this is going to factor for us. And I believe that this is going to factor for us just fine. So we're going to write this trinomial as the product of two binomials. And I think some combination of 2 and 5 will work out nicely here. How about a positive 5 and a negative 2? I think that would be working out splendidly. So let's go ahead and figure out what our solutions are going to be here. We get zero product property going on, and we end up with two solutions. X is equal to positive 2, and x is equal to negative 5. Okay? So we end up with these two solutions here. Now, just like for absolute value equations, it's the same rule for radical equations. We would want to go ahead and make sure to check our answers here to see if we have any sort of extraneous solutions, because we had an x show up on both the inside of our radical and on the outside. So we do need to go ahead and make sure to take that calculator and check both of your solutions here. I think that in this case you're going to be fine. These two solutions will work out perfectly for you, but that would just need to be one of those things that you check with your calculator when you do examples on your own, okay? So again, I've tried to color code the number of the example according to what color or what case we have, right? So let's take another look at another yellow example here. So number 5 is an example of that. So here instead of a square root, we have a cube root. And so again, we perform that first step of subtracting 4 from both sides because we're trying to get that root by itself before we raise both sides to an exponent. And because of course we have a cube root, we're going to raise both sides to the power of 3. So on the right hand side, you see that negative 4 to the power of 3 is going to give you negative 64. And then it undoes the cube root on the left hand side, just leaving you with what was underneath, the 3x minus 7. And then, of course, we're just going to add 7 to both sides and then divide by 3. And we see here that we get one result here, one answer of x is equal to negative 19. So that's not too bad. Let's go ahead and take a look at another example here. And this is not going to be another yellow example. This is going to be our first pink example of the video, right? So this is going to be an example where you have an equation that contains two radicals and nothing else, right? So the steps here say you want to get one radical on each side, which looks like it was already done for you. In number 4, we have the cube root equals the cube root, so that's already done. And then it says to get rid of the radicals. And remember how we always do that? We always go through and we raise both sides to the power of the index. So because we're dealing with a couple of cube roots here, we're going to go ahead and raise both sides to the power of 3 to start us off. So let's go ahead and do that. That's going to undo the cube root and just leave us with 5x minus 3, and that is going to be equal to 2x plus 4. And then from here on in, it's just super simple to solve, right? Because we just end up with this nice linear equation here. I might go ahead and subtract 2x from both sides, in which case I'd get 3x minus 3 is equal to 4. Add your 3 to both sides. You would get 3x is equal to 7. And then, of course, divide both sides by 3. And we get ourselves a solution of the fraction 7 over 3 as our result. Okay? So that's not too bad. So when you have this equation going on, you have two radicals in the same equation, you would just want to go ahead and get it so that you have one radical on the left, the other radical on the right. That was already done for us here in this example, but then after that we would get rid of the radical by raising both sides to the power of 3 in this case, because that was the index of the radical. Okay? So I wouldn't say that anything that we've discussed so far was too terribly difficult. There are some steps involved, but I would say that the yellow case and the pink case, those are pretty straightforward. It's going to be this blue case that's going to be the more labor-intensive example that you're going to have. So this is going to be an example where you have two radicals plus more. And by the plus more here, what I mean is that you have, the radical and then plus a number, right? So something that might look like, your radical expression and then plus 1 is equal to something else like, say, 3. This is the more that we're talking about here in this example, where it's not just the radical by itself. It's going to be the radical plus some number. And that's going to be an example of what we have here in number 6, where you can see here that we have two radicals, and then we have that 1 there, right? So what we would want to do in this case is we would want to go ahead and bring one of the radicals over to the other side. So because it already says minus the radical x plus 4, I'm going to go ahead and add that quantity to the other side, in which case we would see that we have something like this going on. So on the left-hand side, we simply have the square root of 2x plus 6, and that is going to be equal to 1 plus the square root of x plus 4. Okay, now this is the best that we can do to try to get the radical by itself on one side and the other radical on its own on the other side, right? That's the best that we could do to try to get it to look like what we had in number 4. But it's that pesky 1 plus that is kind of messing us up here. But the best that we could do now is just go ahead and try to do our best to undo that radical. So we're going to go ahead and do that by raising both sides to the appropriate power. And when we do that on the left-hand side, that's the easy case. So that's going to be 2x plus 6. But on the right-hand side, you'll notice that what you got going on here is something that looks an awful lot like u plus v squared. And yes, indeed, we are going to have to use that special product formula in order to go ahead and expand this out, okay? And so just remember that if you have something that looks like u plus v squared, then this is always equal to u squared plus 2uv plus v squared. Okay, and so playing the role of u is 1, but playing the role of v is that radical. Playing the role of v is the radical x plus 4. So we're going to have to kind of be careful as we apply this formula here. So u squared, that's simply going to give us 1 squared. I'm just going to go ahead and write it out so you have an easier time trying to match up to our formula here. And I'm going to go ahead and add on 2 times u, which is 1, times v, which is that radical expression, the square root of x plus 4. Okay, and then I'm going to go ahead and add on our v squared, and our v, of course, is that radical expression. And again, just kind of matching up, you had your u squared here plus your 2 times u times v plus your v squared there. Okay, so just applying the formula, that's what you're going to end up with. And cleaning this up a little bit on the right-hand side, you are going to end up here with 1 plus 2 times radical x plus 4 plus, and then because we're taking the radical expression squared, that's just going to undo the radical and just leave you with this right here. Okay, so the right-hand side needs some cleaning up. We can go ahead and combine some like terms there. So we're going to have here, I'm going to go ahead and rearrange some things here as well. So how about the x that we had remaining there? And then 1 plus 4, that's going to give us 5, and then plus 2 times the radical x plus 4. Okay, and it would be at this point that we would want to go ahead and continue to solve this just as if this were one of those yellow examples from before where we have one radical and then everything else, right? So I'm just going to go ahead and move everything over to the other side. So minus 6x, or not minus 6x, goodness, minus x I meant. And then let's kill 2 birds with 1 stone and subtract that 5 over here as well, in which case we're just going to be ending up here with 2 times radical x plus 4 on the right-hand side. And then on the left, we are ending up here with x minus, sorry, not minus, plus 1. There we go. And now we want to get that radical by itself, of course, again. So we're going to divide both sides by 2 to get that rid of that 2 times. And where I've got some room, I'll go ahead and continue here. So maybe continuing over here, I'm going to have x plus 1 squared is equal to the square root of x plus 4. Okay, so I've isolated my square root, and now that I've isolated the square root, it's now time to get rid of the square root. And we, of course, would do that by raising both sides to the power of 2. Okay, and so by doing that, we're going to see that on the right-hand side, we're going to end up here with x plus 4, and then on the left-hand side, we end up with x plus 1 squared all over 4. Okay, it would be at this point that I would want to go ahead and get rid of that divided by 4, so I might go ahead and multiply everything times 4, in which case I would get your x plus 1 squared is equal to 4x plus 16. And then I would want to go ahead and expand out that that other side there, that left-hand side. Again, that is something that also looks like u plus v squared, so I might expand that out into x squared plus plus 2x I meant, plus 1 is equal to 4x plus 16. And again, continue where I got some room. I might go ahead and subtract the 4x over to the other side, again, because I've turned this into a quadratic equation. So subtract the 16x over here as well, and you would end up with the following. You would get x squared minus 2x and then minus 15. That is going to be equal to 0. Okay, and that could be something that we can factor. So we can go ahead and factor that into x and x. And then I believe some combination of 3 and 5 would work nicely here for us. How about a negative 5 and a positive 3? That would give us these two solutions here of x is equal to negative 3 and x is equal to positive 5. So that one you can see is a doozy of a problem, right? So when we have one of those blue cases where we have 2 radicals and more, like that 1 plus from the very beginning, we have a very, very algebra-intensive problem to do here, okay? But those would be the steps to go ahead and actually do that. And then the last example that I want to kind of point out here in this video is just one where you have those rational exponents. We've done these in the past, so just remember, if you have a rational exponent, a fraction as an exponent, we're just going to raise both sides to the reciprocal. You could plug in 27 to the power of 2/3 into the calculator. It's going to tell you that it's 9, and then you just go through and use your inverse operations to continue to solve. Just don't forget that whenever you're trying to undo an exponent of 2, you are going to need to go ahead and use a plus or minus square root in order to go ahead and do that here. So plus or minus the square root of 14, those are going to be your results here in that example. So I hope this video has been of some help to you. Please, as always, let me know if you guys have any questions whatsoever. And I'm trying to get rid of the keyboard there. There we go. And yeah, that's all I have for this one, guys. So remember, if you have one of your radical equations, always be sure to be using these steps here, and always check your answers. Use those calculators. Check your results. So that's all I have for this video. Thank you very much for your attention, and I'll speak to you in the next one.